Good afternoon, those who have joined from India and APAC region, and good morning to those who would have joined from European region. So, respecting the time, we will just start with good afternoon, a short refresher, and once after that, we will get into the main webinar. So, we will give few minutes for others if there are any technical glitches for them to join this webinar. India and APAC region. So when I start, I just would like to morning to those who start it with from European region. Short refresher of our own memories when we were in the school days. So I think almost every one of us have we will get into the learned this formula. So a plus b whole square is equal to a square plus 2ab plus b square. And we were just asked to derive it with different methods. And one of the simplest method was this expression was divided into 2 with a plus b into a plus b. Now with the distributive property, we could just multiply one factor with the a plus b, then the other factor b with a plus b. So which gives a square plus ab, then ab plus b square. So thereon we arrived at like a square plus 2ab plus b square. Well, this was how we were learning it from many years during our school days. Did we ever think about like how this can be done in a geometrical way? Let me take a line and I can split it into two segments, one A and the other one as B. So I'm taking 3 more lines of the same length and I'm just going to create a square out of it. Since all the lines are of the same length, I can divide it again into the same line segments A, B, then again A and B and AB. So now with each side, with A plus B as its line segment, we can call this as A plus B whole square. Now let's see how does it look like when we have this A and A on a horizontal side as well as a vertical line. If we can just align, then we can see that there are 4 different squares or 4 different quadrilaterals which are available for us. So the one on the top left, you can see all those sides with the same length of A, and definitely we can call this as A square. Now there is another one which has got all the 4 sides with the same length B, and this is B square. Since all the edges are perpendicular to each other, these are squares, and then there are 2 other quadrilaterals which is having length A and breadth B. So it's length and width as AB, and there is another one with length and breadth as AB. Now do we see that geometrically as well we can prove A plus B whole square is actually A square plus AB. Well, so give a thought. Then what would have been easier for us to learn during the school days? Was this theoretical one was better, or do we see the geometrical one is much easier? Of course, many of you may be getting a question now, can we do something similar even for A minus B whole square? Yes, of course, but you can just give a try for that. Well, I hope now we may have some more participants already joined in. So with that, we will start with today's agenda for our webinar on empowering the smart factories in the challenging times. So our agenda is an introduction to organization disrupts. Then we will have a quick look at like how digital manufacturing can help building the smart factories. In the smart factory, what are the different ways that we can just build it? One is the design part of it. Then how do we build the process? Then we can just have a look at a product demo from our end. At the end, we will have some questions. If there are any, then we will just address them. Desapex as an organization is headquartered in Bangalore, and we are located in the European region, headquartered in Stockholm. Globally, we are present in multiple locations with respect to our projects. So it spreads from Australia to Middle East and even to the US. Our mission is to enable digital adaptation and integration of technology for target value design. And we come with a vision of sustainable built environment. We are the first one in India to have BSI kite mark, and we do hold even the first one, even in the world, when we started this. This is our team. So we are 120 plus and growing. So located in Bangalore as well as another city in Karnataka, Hubli. And we have few key people working from other parts of the world, especially in the European region. Within the Desapex organization, we have 4 verticals: digital design management, digital project management, digital asset management, digital engineering and manufacturing. So as part of digital design management, we do clash and detection coordination, and then we have even BIM-based pre-construction services. Under the project management, we do look at like digital information delivery plan and setting up of the digital lab. Under the digital asset management, there are services like scan to BIM, and then we have even the asset management. Digital engineering and manufacturing covers product development, CAD, automations, CAD application management, and digitalization of the manufacturing industries. When it comes to digitalization of the manufacturing industry, there are different ways. So even today, we can see that there are many organizations which would be established 20, 30 years or even 4 to 5 decades before with the latest technology available during that time. But now we do see that with the advancement of technology, those organizations are facing a situation where it would be a huge cost to upgrade their infrastructure. But at the same time, we propose there are few areas which are kind of low-hanging fruits, which can serve definitely for them to look at like how quickly they can become smart factories. There are some of those areas where even Desapex has even shared some of the presentations in the past or given some webinars. Training using the virtual reality. You would have seen our webinar on lockout and tagout. So which gives an information around like how maybe virtual reality can train an employee on any of the new equipment. We have the technology for 3D printing, where the prototyping is an expensive thing, then 3D printing would be much cheaper option for people. The organizations or the industries can look at the plug and play predictive maintenance tool, which are rightly available in the market nowadays. Data analytics is something where we from our organization can help in identifying the trends of like how the machineries are running, and we can just support in making the decisions which can help predicting the equipment failures. At the same time, we can just even identify some of the quality issues with the products. When it comes to quality issues of the products, so digital quality analysis is one of the new technologies. Again, we have provided another webinar on the same topic in the past. So where digital technologies, with the digital technology, we can scan the product, we can validate the dimension against the CAD models, which is a much simpler at the same time, which is more accurate quality analysis process. Virtual factory is a trending word, but we are looking at like how do we help our partners or our customers to make this virtual factory in a faster and a quicker way. The traditional format is we do take some of the 2D drawings available, and with that, we assume many things, and then we start creating the 3D model. But with the latest technology, I think it is time to go for us to look at like how scanning can help them in creating the virtual factories. Just taking you through a short video where we can just see how digital factories are being built today in today's generation with scanning of the entire factory premises. Then we convert those scan into a CAD model. So what you see here is the factory itself, but we have converted this into a point cloud with the scanners that we have carried, and this scan data will be used for as an input for us to create the next level of information which the factories can use for different. So have a look at like how the factory is being scanned from different angles and which of the areas can be covered in a quicker way, which probably may not, it is not possible when you try to do it with a 2D drawing. Along with the scanned point cloud data, we capture even the real-time images as well. And with both of these combined together, we create the CAD model of the factories. So once these CAD models are created, each of the parts or each of the assemblies can be segmented into different categories like for the customer requirement. We can put electrical components in a separate category. We can put the machineries in a different category. We can keep all the specific assemblies areas in each of these sections. And it allows us to create some of the annotations which can classify which area to be proposed for what purpose. With these CAD models and the rendering effect, we can visualize the factories, how well it can be seen even in the virtual world. So there are even the catwalk areas or the areas which are above the ground level, which we can just take a walk through, and then they can just show that like how the visualization would be from different angles. So that was about how we can do the virtual factory creation. That's the first part when it comes to digital factories. Digitalization for scenario planning is what needs to be done when we talk about digital factory. That's the first part, which we call it as design. And the next one is about build. So when we are going to build anything, we need to look at like what are the best possible simulations that we can do. Most of the time, we go with the normal method of pen and paper or nowadays with the Excel sheets. But with the latest technologies available for us, we can even simulate combining the product data, which is already in the CAD model, and now having even the digitalized factories. You can look at like how the simulations can help even for process implementation or process analysis. And the next step would be operation, where it is combination of physical and digital systems connected in the real time. When it comes to build, the simulation and risk mitigation, what we need to do, we have looked at multiple options and we have identified the factory simulation could be done in a very good way, or in the best possible solution that we could find is one of the tools called FlexSim. So FlexSim, it's an company which is founded more than 30 years back. And now in recently, later after 2000, it is named as FlexSim Software Products. It is preferred by most of the organizations across the world. It is even used in railways, many of the hospitals, even there, apart from the manufacturing organizations. This is a company now associated even with Autodesk. So we are looking at this as one of the best tools for us when it comes to factory simulation. So before we get into the actual build, let's look at like what we need to understand with the build. There are different category of objects when it comes to building a factory inside a simulation model. There are flow items. It could be just a metal piece which will undergo different process like milling, drilling, fine, the last finishing applications, or it could be even assembly, where we will have a main component and inside which all the subcomponents will be assembled, or it could be just a packaging where there would be labeling and other process done on that. Next one is fixed resource, which each of these flow items, each of the parts or each of the assembly will be going through. So these fixed resources could be like the stations on which the specific activities are completed. It starts from the docking area where the parts are being stored. Then it comes to a location where it is queued for the next process and it is the actual process area. Then it is getting moved to the final storage area. So these are all the fixed resources where the flow items are getting moved. For these flow items to be moved from one to different fixed resources, we need something called task executors. The task executors could be the human themselves who can just pick and drop in different fixed resources, or it could be forklift trucks, or we can have some of the robotic equipments also nowadays. Basic understanding of this, we will have a look at how this is used when we create a specific simulation model. So when we get into FlexSim demo, we will be going through three different level of understanding of the application. So one, we will just look at like how the process can be configured. In the second phase, I'll just share a little more around how the process can be analyzed. And then the third one is around experimentation. That's considering the audience. So we know that there would be few beginners for whom it would be interesting just to understand the configuration. The people who carry some experience, for them, it is much important to know the process analysis, and the experts in the industry, for those who would be working in the industrial engineering, experimentation is something which makes it really valuable for them to take some decisions. So with that, I'm just taking you to the tool FlexSim, which is by Autodesk. So as we were looking in the basics, like what are the different types. So we have categories already created in this application FlexSim, which says like fixed resources. Then we have task executors. And once we start setting the fixed resources, you can see here, this is a source. So when I'm creating it, I'm just doing some modifications in this. We thought we will have a live demo. If there are any technical glitches, we may move to a video. So we have this fixed resources where we set the source. Then we will have a queuing section. So in which if there are flow items which are not moved to the processing, they will just remain. Then we will have a workbench on which the actual task is getting performed. And then we will have a place where the work which is already completed will be stored. So as part of the simulation, we need to connect the flow, how the part is going to move from one station to other station. So I connected it from source to queue now. Now I'm connecting it from queue to processor, and then from processor, I'm connecting it to a sink. So if I just give it a run command, I can see If there is an object coming, you can see a box and then it's moving to sink. But this doesn't look much realistic, right? So we can just, let's try to make it in a little more better way, how in reality it would look like. Add an operator. So these are the options which are already available in FlexSim. That's the beauty of this tool. So I am just going to add a robotic arm, which will take care of moving the finished product from the processor to the sink. So when I just add these two task executors, it's equally important. This being a simulation tool, we need to inform these tools if there is a operator who is going to pick the object from the queue. So here, as I said, like this operator will pick it from the queue, and at the same time, this robo is going to pick the object from the processor. When it comes to queue, I think you would have observed there is another tab on the right hand side which keeps changing whenever we are clicking on it. So under properties, I'm just asking it to use this transport. And now if you just look at how it is working, a person is picking the object, is keeping it in the processor, then the robo picks it once the processing is completed, and it is dumped in the sink. It looks a little better or a little more realistic, right? But let's try to make it something more interesting or practically how it is being used. I'm just taking out this sink here. Okay, and let me just, in that place, I'll just bring a queue once again. So here, if you look at, like, there are a lot of other tools options which are available, and most of the factories what we have seen, racks which are used to place. This looks more realistic and the right way, like how it is being placed. And I'm just keeping it in a random way, just for us, for a better visualization. When we just give some more animations for this. So now we have multiple transportation options here, task executors. So let me add one more transporter, which now looks like a factory environment. So you have a forklift truck. So as we did in the past, so we need to connect the processor to the queue, and queue where the object should go. It should go to the rack. But at the same time, the transporter should know that from where he has to pick. And again, we need to inform this queue that there is a transporter who will pick it. Let me give a dry run and check if it is working. If not, we may have to test something else. No, it's not working. So you can see that the object is being picked. It's put in the queue. The forklift truck is taking it and placing it in the proper sections of the rack. So you may be assuming, like, how much time it's going to take now for us to look at, like, how this is going to work. And that's where we need simulations, right? So simulation, when we do that, like, it is to create the real-time scenarios, but in lesser time. So what you see here is now taking around, I can just set it to 10 seconds. So which is actually in real time, it is 1 second, but it is working equivalent to the 10 seconds period. and we can manually drag it and increase the time period. So where we can see like how within what time it's going to just fill all the places. Well, so this was more about like the feasibilities or the possibilities that is available with this tool FlexSim, just to show that how it can simulate, and that is only the first part of it, where we are just only creating a process, but how it is really useful for engineers. So let's quickly just go ahead and create one more model here. I'll just take out, so these were just some of the examples what I could just give for you to understand the capability of the tool. So I'm going to create the sink once again, where we will keep the object. For engineers, what's actually needed when it comes to process analysis is utilization of the resources that's available with us. So the resources what we have is operator, robo, and the processor. The other items are more of a storage, and we need to analyze like how is this being used. That's where the next level of analysis comes into picture. So we start using dashboards now. So dashboards allow us to create multiple statistical information. When you look into this, you can see that how matured is this FlexSim tool when it comes to the statistical data. So for now, I'll just pick state and a bar chart in which I'm going to take two objects to be analyzed. So we will pick the objects which needs to be analyzed. One is the operator and the other one is robot. And the second one, I would like to see how I can look into the utilization of even the processor which is available for us. There I'm just going to take one another chart. And we have seen like how the speed can be controlled. At the same time, we can even look at how the time can be set. So by default, it takes a shift time which starts at 8 in the morning, but we can even set the stop time. Let's assume it goes till 4 p.m. in the evening. Whatever we are going to simulate, it will directly start from beginning of the day till end of the day. We can just have a look at like how this is going to work. Before I create anything, I need to just set this and let me just quickly do a dry run. So you can see that there are objects coming from source, which is coming into the queue. Operator is picking it, keeping it, and again the robot is picking it and taking it to the sink. And once we increase the speed, so we can just simulate it. And here you can observe the efficiency and the utilization of operator. So here it gives a graphical information about like what's the empty travel time of the operator, what's the empty travel time of the robot. At the same time, like how much is the idle time. Since the person is just waiting here for the next command, he is being idle for most of the time, since there is no other queue options available for us. So this is a little advanced stage of like how the analysis can be set. Stop at this level. Now with this analysis, what we have, it's only giving us the readings or the information about how people are working. But then how do we go ahead with define what would be the better option for us? This is what we were looking at process analysis for advanced users. Imagine we have a source from which there are around 10 items coming per minute, which are coming to the queuing station. In the queue, So here I can just share with you like queuing station, and we will have classic 3 classic processors. So with this, you will see the actual problems what usually we will see in the industries. So we will have 3 different processors. By the way, all of these can be renamed. We can just go to property. I can just mention it as store 1, and there is Q1. We can just change the name, the station. So how you prefer to keep it? Like you have the options to rename these according to the nomenclature, what is available in your unit. And then I'll just create another object here, which is a sync. So here comes the next level of industrial engineering, where you need to know, or we have to analyze, what's the statistical way of input of the data. So when you look at the inter-arrival time on the right-hand side of these properties, so it picks the way how we define the arrival of the objects. FlexSim again as a tool, the beauty is there are 10 to 20 different, which I did not count exactly, but at least 20 plus different ways of inter-arrival time. So we have exponential, we have triangular, we have logistic. I mean, there are different ways how it can arrive. So if I just go and change it into, you can see here exponential way how it comes. In the same way, if I just go and change it into triangular, this is usually the statistical way, the minimum, maximum, and the mode, how the inter-arrival time is getting changed. So for the current activity, I'm just keeping still as exponential, and from exponential, from the store 1, we move this object to Q, and let's connect this object from Q1 to multiple processing units or multiple test stations. Once all the activities are performed on this processing stations, the objects will go, and again they will be loaded in a final stage at a sync. Now if I just go for a quick run, I can see that the objects are going to station 1 and from there to sync 1, and similarly it's coming to station 2 and then it's coming to processor 3. So I'll just reset this. So now what we need to do here, so we have a test station where we know the processing time could be 30 because there are 3 stations. Let's just assume that it takes around 30 seconds in each place to complete the process. And now, as we have done previously, I'm just adding a dashboard to get information about like how is the statistics of each of these processor being utilized. We can just pick test station, processor 2, and processor 3. And then let me look at like how much is the quantity which is arriving in the queue. So as a content, if I just take it in a tabular format, so now if I just go for running this as a simulation, again we can just define the time, start and stop time. If we start this process, this is how the tool does the simulation. So here you can see the processing is being analyzed, which would take entire day for us if we have to go with the real time. here with these kind of FlexSim software what we have. So I can just simulate it for the whole day within just few minutes, and it gives us statistics about how the processor is being used, what's the queue time, what's the average time. And we see that in queue, there are still many more boxes left. So which we need to look at, like what could be the improvement. And here is where the actual industrial engineering comes now. So now let's again do some improvements in the processor. That's the best way of improving the overall process, because the options left with us, one is reduce the store one quantity. That is, whatever the customer requirement may be coming, we have to look at like how do we reduce it, which is not practically the right option. The second option could be we can increase one more processor or one more test station. Even that could be an expensive option. But the easier one, what we can work on is improving the process. So which is going to take around 30 seconds of process time today. So we can just try to reduce it by 10%, which is practically possible. And I'm just changing it to 27. So with this, now again, if you run the simulation, can look at like the Q1 content, how much it's going to be by end of the day. So which was around 26, now it came up to 9. So this is where the advanced process analysis will help the engineers when they have to do any kind of changes or improvement in the area of their current setup, how they have, once they have all the right information, then we can just experiment it, like what could be the different numbers we can just bring in, or what are the different additional task executors or additional fixed resource they need to bring. Look at more about like the examination part, which the tool will offer. Let's just have a look at another video. It's a video of around 10 minutes, which takes you around one of the case studies where we can see different colors of paper bundles being combined, and that's getting under the testing and then into a different processing. So how much time it's going to take, we can just have one experimentation analysis.
Experimenting allows you to identify key inputs and outputs to your model to find different combinations of values for inputs, and lets FlexSim run many iterations of those different scenarios. Once all scenarios have been tried, you have access to reports that let you make side-by-side comparisons between them. There are three key elements that support this workflow: the parameters table to identify the inputs you want to experiment with, the performance measures table to track the KPIs for the experiment, and the experimenter control itself. Here's an example model where we can see this in action. It's really simple. Parts arrive in random batch sizes at random intervals of time with random potential product types. They're transported to a tester by an operator where they have a random test time. There's a 20% chance that parts will fail this test and need to be reworked. Good parts continue to a packing station to be packed and shipped to customers. The combination of parts packed together is always the same: 4 red parts, 2 green, 3 blue, and 5 yellow. This model with the purpose of figuring out how we can maximize the number of pallets that we produce in a day. And we want to study the effect of an additional operator versus an additional machine versus a lower failure rate. Which of these options will produce the most, if any, benefit, and by how much? Because there's variability in this system, a single run of the model isn't going to tell us much about what we can predict about its outcomes. A lot like how a single game doesn't tell us much about a player's performance in the future. In experimentation, we run a simulation model a relatively high number of times and gather output data from all those model runs to tell us how a model can be generally expected to behave. Let's have a look at the different touch points for the experimentation system. Firstly, here are the parameters with the size of our operator team, number of available testers, and our test failure rate established as inputs of interest. On the performance measures table, we are tracking the number of pallets per hour as our output of interest. Next, let's open our experimenter control by going to the statistics menu. We configured our experiment job with a 1-hour warm-up time, a 10-hour runtime or stop time, and we've also established 30 replications to be run for each scenario. Below that, in the scenarios table, we have configured the different scenarios that we want to define for our experiment. Notice here we have a baseline scenario with a team size of 1, a number of machines of 1, and a failure rate of 20%, indicating that this might represent the current state of the model as it exists today. Below that, we've added another scenario where we say that we're going to add a team member, but notice that I keep the variables the same for the number of machines and the failure rate. Here, I'm trying to isolate the effect of just adding a team member on the model without worrying about any other confounding variables. On our next row, we have added machine as another one of our scenarios. Here we'll have a team size of 1, number of machines of 2, and a failure rate of 20. Our fourth scenario, we've said that we want to see what happens if we could reduce the failure rate, and I've set the failure rate to 5%. Now, if we come to the Run tab, we're ready to run this experiment. So as you can see here, we have all of our scenarios queued up and ready to run. And so when we hit run on this, the experimenting engine begins to go to work.
So this is one of the scenarios which is being tested. Like the usual way what we work is adding either one task executor or one machine, or we just look at like how the failures.
Now this is something that can take some time depending on the size and the complexity of your model and how many scenarios and how many replications you choose to run. And the rate at which we can complete an experiment is pretty dependent upon your computer specs. Now we can see that all of our scenarios have completed and we're ready to see our results. We come here to where it says view results. You can see now how our different scenarios stack up against each other. Here we can see that on our baseline scenario, we can expect an average of about 5.85 pallets per hour. Each dot in the scatter plot represents the output of one replication of the model. For example, if you mouse over one of these red dots, you'll be able to see that this is the number of pallets per hour that we got during replication 21. Compared to another dot, this was the output value we got from replication 26. So a difference of between 5.33 pallets per hour and 6.44 pallets per hour. And now we can compare this to the result of adding a team member, and we can see that we have about the same minimum range of about 5.22 pallets per hour, but a much higher maximum of 7.78 pallets per hour. Here, there's a lot more variability. The range of potential values is much greater, but the average is 6.56 pallets per hour. And that's a gain of almost a full pallet per hour, right about 0.7 pallets per hour if we can add a team member to this system. If we take a look at our results for adding a machine, we can see the results are pretty similar to adding a team member with an average of 6.48 pallets per hour. And then if we were to reduce failure, our average sits at about 6.45 pallets per hour. So it looks like whatever we choose to do with this system, we can expect some pretty decent gains, but at the cost of a little bit more variability compared to the much tighter range of values on the baseline. This scatter plot is one way to view your results. You can also come to this menu and choose to see a frequency histogram. If you wanted to see your results distributed like a statistical distribution, what kinds of values of our outputs are more likely to occur than others. For example, here on the baseline scenario, we had 8 replications that fell within 5.78 pallets per hour and 5.99 pallets per hour. Another useful way to analyze your results is to look at the scenario comparison chart, where here we're doing a test for statistical significance between all of our different scenarios. So initially, it does the comparison based on the first scenario. And so compared to the baseline, each of our additional scenarios is statistically significant compared to the baseline. But if we change the basis for the comparison using this menu compared to reducing failure is not statistically significant different from adding a machine, but it is compared to adding a team member and the baseline. In addition to these reports, you can also see information gathered by the experiments or related to your dashboards. Here on the Dashboard Statistics tab, you can see that if you had any dashboards in the model at the time of the experiment run, data for each scenario in each replication for each of these charts is gathered here. For example, this width versus time chart is showing for the baseline scenario, and this was the result that we had on the chart for replication 1. You can also see here for replication 3, replication 10, and so on. And you can see this for any of the different charts that we may have had. And again, the reason why we're seeing so much difference in each of these charts from these different replications is because each replication represents a different set of results given one set of random inputs from all the randomness variation that we built into the model. So even though the model runs with the same inputs, because of the randomness, the outputs that we get are a little bit different. And again, this is why we want to run many replications per scenario so that the variability caused by that randomness can be kind of evened out in the results that we get. Now that we've explored some results a little bit, it's pretty common to start asking yourself some other questions about how the model might behave. For example, since we know now that changing the values of any one of our parameters, any one of our...
Well, so we have seen like adding one of the parameters. Now we can see the best scenario where we will add one team member and one more machine, and then we will see that even if the failure is reduced to like 5, then how this is going to work for us and what would be the ideal condition for an organization.
Per hour increase in our output. Maybe now we're wondering, is there a way to maximize this? If we were to potentially change maybe all of the inputs, could we really maximize our throughput? So what if we add another scenario here? And maybe we want to name this something like max out. We want to see what happens if we could have 2 team members and 2 machines and a little failure rate. What could that do for our system? Now we can come back to the Run tab and we can see our new max out scenario is queued up and ready to be run alongside our other scenarios. But since the other scenarios are already completed, we don't have to rerun all of these. These scenarios are already recorded, their data is set, and now we just have to hit run and we will begin executing the replications related to our new scenario. Let's have a look at what that did for us. So if we come back to viewing our results, again, we'll open that same report window that we saw before, but now we have our new max out scenario added to the end of the columns. And kind of interesting here, notice that the max out scenario appears to fare no better than the other 3 scenarios. Average on max out, 6.6 pallets per hour, and again, compared to what we would probably consider our best scenarios so far, the adding a team member also about 6.6 pallets per hour. Are these results a surprise? What would you have predicted them to be? This happens quite a bit when analyzing a simulation, where the results it generates can be surprising, and that's actually a good thing. One of the most valuable things a model can do is challenge your customers' assumptions or expose bias about how they think about their processes. The simulation can confirm what you already believe about a system, that's great. But how much more valuable is it if it can reveal something they didn't anticipate? It could even prevent them from making a costly mistake. We've built many models over the years at FlexSim that have done just that.
I think that would have given like view about like what is the advantage, real advantage, like when it comes to adding a machine or adding a team member or even by doing both. So we could see that there was really not big difference when it is compared with only one of them being done gives the equivalent results. Just adding a team member and adding a machine with the team member, there was not much difference for us. So it really saves from making some of the costly decisions or the expensive decisions in the real-time factory areas where we have to take some decisions. These are the reports which will be helping us to take it forward and get any kind of future references that we need to do. Well, so with that, I'm just again taking you to a quick back to our look at like how the digital factory and what are the different stages. So we have seen like digitization, then simulations with three different ways. Like one is setting up the process, second is analyzing the process, then the third one is examining the process or different scenarios, how it can be tested. And then the last one is the real time, where it will be used in the factory, how you can implement it, then how you will be using it. That is something which will come in the real time. So, what are the challenges today? So, we know there are geopolitical situations which are stopping companies from investing a big amount, and there are environmental concerns which are again stopping the organizations from experimenting a lot. At the same time, there are technological advancements which are forcing the organizations to implement or come to the market in a quicker way than how it was running in the traditional format. Looking at all these challenges, it's time for almost all the industries now to adopt in a quicker manner how they can just bring in simulations to their process and take those benefits of, like, it could be the system representation that they want to have, it could be the decision making that they want to make, or the optimization in the existing process, like how we can reduce the time of processing time or utilization of the human resource or utilization of the machines what we have. At the same time, identifying any of the risks and mitigating is what we do see the advantage of simulation. So with that, I'm taking you to the Q&A session. So I'm just looking at, like, if there are any questions, please feel free to put them in the chat window or the Q&A window tab you have. Okay, right now I don't see any questions, but just again, when it comes back to the FlexSim tool here, so we can just look at, like, the features available. We can just build the factories, conveyors, so which are possible in a just few seconds. I think you can just drag and put it, like you can join the conveyors, you can just make some decision points, you can join multiple conveyors. Similarly, you have almost all the options which are used in the actual factories or the real time. So these can be directly fetched, and we have the options to put the attributes, the real time attributes for all these conveyors, all the task executors. So then, just back to what we were looking before we started this webinar today. I think the education system is already moving from theoretical studies to simulation. Let it be the functioning of heart, kidney, or any other body organs, or let it be even with regard to the flights, they are using simulations. Now, the question is, are we still at the era of looking at, like, working with all the flow charts, process charts on paper? Or it's not us to look at, like, is it good decision to go to simulation, but it is something that we need to decide how quickly we can go to adopt these kind of tools, and which can help in improving the productivity of any of the organization. Well, with that, we from Desapex wish all the participants who have joined today's webinar a very Merry Christmas and Happy New Year in advance. And thank you for joining us for this webinar. For any queries, any questions you have, or if you're looking for any of our services, do reach us at our address, which you can find here. Thank you once again. Wish you all a good rest of the day and a nice